So we're going to design and build the motor conversion kit for this lathe. We're going to use a 1 horsepower servo motor. Yes, it's custom made as well. Stickers if we build in. Speed control switch, they're custom made. They're not 5s, they're not 10. Custom made and polished belt drive. That's not the right belt, but it's the right width. It's much larger than what this comes with. Display unit. We might put it up here in here, we might not. It depends. The kit has to be easy for somebody to build it themselves, and that's probably pretty difficult. If it's too difficult, we'll put this custom made board, custom upgraded board, in an exterior box, which is normally mounted up high out of the way. One of the problems with this lathe is they're popping not only motors, but they're popping the main control board. This back in this box back here, and it's open to metal filing, so it's of course gonna go kablooey really fast. This is brand new. If you watch the other video, you already hear the motor's ready to fail, and all I've done is set it up and get it ready to cut. That took, wow, it took about 10 hours just to make this lathe usable from the box to on the bench, and it's still, the motor's still junk. So when we get done, it'll be really nice. Before you do any work on any of the electronics, actually before you stick your hands in there anywhere, unplug it. That way you don't let the smoke out or chop your fingers off. Remove the reversing switch. We're not going to use this with the new system, so you won't need it. This plate should snap out. Just get a little small screwdriver underneath it or something. Comes out like that. Screws. Unscrew these 6 Allen heads on the back of this plate. Pull this plate out. Mark these wires on the magnetic switch. Notice I just marked a couple because there are several with multiple same color. I gotta put that one back on. Anyway, unplug this switch, pull it out, plug that switch back into the wire harness in case you need record of where it goes later. Unplug these 2 wires from this board. They are both unique. We're going to pull this box off with these 4 Allen head screws. We're going to pull this board off. We're going to set all these electronics beside. We're going to mark the motor, the blue and white, on the reversing switch so that we can put it back together if we so decide, or if we pass these parts on, it'll help somebody else put them back together. We got the whole back electronics housing. As you see, it's wide open to metal filing. I want you to notice, the seller said this was switch safety. There's no switch mechanism on it at all. If there was, I'd probably wire it in, but because there's not, I don't know. It's a whole lot of cumbersome, and this is always going to be dirty anyway, so it's up to the buyer of this lathe, or you, if you build your own, what you want to do with that. Probably should leave it on there. So we're going to remove these 2 screws, take that piece off. This screw, set the sensor aside. That's the RPM sensor for the spindle. Then this screw and this here screw come off. We take the cover off, and then we'll have access to the belt. Removing the cover exposes the belt. There's an actual improvement on this machine here versus the other 3-inch. This is polished, it's smooth, it's probably aluminum. I'll touch base on that. The spacer is either part of it or it's also steel. If you're trying to get an accurate speed reading on your chuck, remember this has 4 magnets. I've heard reports of these dropping magnets because I get complaints about my engine RPM is not matching the spindle RPM and the gear ratio, and every time it's missing 1 or more magnets. Remove the control board and insulating plate from this back plate. Leave the plug in. Notice we've got a fuse, power supply, ground. We're going to change these colors though, because Coming out of the plug, black is line signal, hot, and white is neutral, and they got, as usual in China, they're running the neutral as a red, which is very confusing for people in the USA. They see red and black, they think 12 volts. It's not. Remove these 4 Allen head screws to remove the display plate first. One thing to take note of, this plate is warped. There's a large gap right here. All the metal filings that land on top of this can fall right in here. So metal filings fall right here, land right here, let the smoke out of this. The speed sensor has to be unplugged like this and come out this way. That way it fits through the hole. Set this whole thing aside. Remove these 2 Allen screws, remove that plate. Something to make note of, on the better lathes, this is actually a gearbox, and the lead screw is reversed by a switch here. There's a gear system mechanism in here, instead of the cheaper version, Chinese mini lathe. You'll find this on Grizzly lathes, but you're going to pay for it too. The price is going to go up considerably for that. I've been trying to find a kit to convert it. So this lathe has the drilled holes right here. 2 holes drilled, no slots. We're going to slot it most likely so it can use the original mount that we're already making all the time. Notice right here there's actually a stamp of where the slot's supposed to be cut. I've cut them there often and it's worked, but it proves that it's the same casting that they use on all the Chinese 7x14s. Being that this is not slotted, we're going to have to take this off, we're going to have to take this off, we're going to have to take this off, probably going to have to take this off. Of course the motor's coming off next, and then we're going to cut the slots in this. As soon as that motor comes off, we'll look for a different option, but that's probably what's going to happen. There's a couple options to remove this. Of course, we can't just slide it to the end because it's going to hit that. Maybe we can take this off and just slide it past without that part there. Otherwise, we're going to have to take the half nut out, and that's an adjustment, and it's a pain to get it back in. So if we can avoid it, we'll try it. 14mm nut, hold this gear. Loosen this nut, remove these Allens. That comes off. Hold this so it doesn't catch. You need to be real careful on this long lead screw. It's really a non-replaceable item. This one nut. And then these 2 Allens, and I should be able to pull this off in one piece. This is going to have considerable weight on it, so you're going to need to support it. Okay, so there it is. It's off in one piece. So we're going to pull this motor off. Notice the belt's nice and tight. There's an adjuster system underneath here to push it down. But how's it going to move? It's like they must drill these afterwards. A cheap Chinese shortcut. If you can't tighten a belt, which there is no way to move the belt up and down or back and forth. This can move a little bit for alignment. That's it. So that's the complete motor assembly and all the electronics now removed. Set those aside. I don't know what I'm going to do with them. So these holes are a little bit bigger than they need to be, so that allows just a tiny amount of adjustment from these bolts that come down from the back side. If you have slots, you don't have to do this portion. Back up, because the only way reason why you have to do this is if you don't have slots. And looking at it, I wish those holes weren't even there, because I'm going to cut the slots where they're supposed to go. That way it'll fit the original motor, I think. We got to look at this too. And they got a different bearing style here as well. Look a little closer. We're going to take this off and look. Remember my first video on my first mini lathe mod where I had to use a hammer to knock this loose? You really need 2 tools to do this correctly. So remove the 2 spindle nuts. Remove the magnetic sensor. Remove the steel gear. Don't damage this gear. Somebody's going to want it. If you're careful and you have the right thickness blade, flat screwdriver, you can press at the inside edge here and turn it. And just kind of work around until you break it loose and then wiggle it off. This gear just slides off. Remove the small key. Remove this metal spacer. So we tried this way, that don't work. We tried this way. It is the right diameter. It's too far out. And it misses the keyway slot that way. If we put it this way, it's too far in. If we move it out to where it's supposed to be, it barely catches the keyway. About 1/8 of an inch. It's probably enough. This probably needs to be redesigned for this one. We'll get one of the old silver ones and machine it a little bit, or we'll make a spacer. We're going to get to that point after we deal with the slots. Remove the 4 large Allen head bolts and remove the spindle head. While you're at it, on the back side there's 2 little bolts with lock nuts on them. Might as well remove those too, because you're not going to use them with the new motor mount. Remove the lathe bed from the workbench. Also, if you're going to take this to a machine shop, take that off, because when it comes back it'll be missing or damaged. So don't take that to a machine shop with that piece on there. A little bit more info about the slots. This is what our current motor mount looks like. This is your horizontal adjustment. It's locked in place by these 2 Allen set screws. These Allen set screws sit in the slots. So when your slot's there, you can reach through the slot and lock the motor in place horizontal. And then the slots up and down are your belt tension, up and down. These holes are in the wrong spot for our motor mount too. They need to be where the slot is. So the slot has to be cut where it's actually stamped in the bed. Otherwise it won't come out far enough. The slot could actually go that way a little bit further. I might cut the slot that way so I don't have to weld the holes. This is how we're going to slot the bed. Again, if you got slots, you don't need to do this, but we'll just clamp it in the milling machine. Set up. It's apparently 30 millimeters center to center across. I don't know how long it is. 11/32 diameter cutter. It'll be really easy because I have the tool. If you don't have a milling machine, I say you better find somebody that does, because you're not going to cut this by hand. Okay, there it is. Slots are cut. Mount it back to the bench. Motor sits in. Notice slide. Sits in like that. See the set screws? Those are your sideways locks. This is your vertical lock. Put this piece on first before you put the motor on, because you need the access to get at the back screws. It'll come in the kit with this installed. This will be installed. The nuts will be on it. You take those off. Put the motor in the back. Thick washers. Just let it rest there for now. Leave it a little loose, because you're going to have to adjust things like this. We're definitely in the right range too, so if you're slotting your lathe, Don't follow the cutouts, the stamps exactly. Actually move it over. It's about 1/8 of an inch farther over this side. Put the head on, and we see this little plastic thing here. I don't know if that's an error during assembly or if somebody put a shim in to change the tip of this a little bit. And I guess we'll leave that one piece there. The other piece fell off. Screw that down. The original design has a metal ring. This is a little shorter one that I made. And then this part goes on here. And then they have a little teeny weeny 4mm keyway that only catches the end of this, like this. Not very much, about 1/8 of an inch. We fit ours in there. It catches a little less because we have to pull it this way. We spun it up and shut it off, and because our motor has so much more power, it just sheared it right off. And then the chuck would, there'd be some drag, but it was almost free spinning. That little keyway is supposed to be pushed through this gear by this. And if the original motor had any torque at all, it's only got a little bit more of this early version belt drive. It would have sheared it off too. So the only real fix here is to take the spindle shaft out and cut the keyway slot like it should have been all the way down. Which is what we're going to do. That's also the correct fix if you're going to convert a 2-speed mini lathe to a spindle drive, which I highly recommend because it's a way better system than the high-low gears. Once it's done, it's quieter, it's more powerful, and you have a better speed range. All right, we're going to get started and cut this. I'll show you a little quick short when we do it. Also, these bearings are, well, they're pressed in. And probably going to require a press to get them out. So that's what we're going to do. Before we take this apart, and since we've already indexed the chuck, this is key number 1. So we're just going to put a number 1 right here on the spindle so we know to put it back in the same place. So a good question here is, can this be done by the backyard machinist? And we're going to try it with hammers. We lock the 2 nuts together, and they're just a little bit past flush of the end of the spindle. If you burr up the spindle, you got a big problem. These, when you twist them off, you're actually hitting the nuts. They're locked together. When you twist them off, if there's a burr on the spindle threads, they should clean it up. Otherwise, you're going to have to file it. We've already knocked it and it's starting to move, so this is what we're doing. We're setting a hammer on it like this, and we've got a big hammer like this, and we're going to drive it out and see what happens. It's out. That wasn't bad. Okay, you saw how easy that came out. It's just a little metal ring that's pressed in there. It's really a filler. The bearing itself, it's a decent fit, but there's no way to really, there's no way to put tapered roller bearings in this lathe the way it is. There's no way to put angular contact bearings in this lathe the way it is, because there's no way to lock them in place. This isn't going to make it. There's no reason to even put a better bearing in. I'm not going to bother. The only thing that there's 2 ways a person could approach this. They could make a plate on the outside and screw it on here, but that's going to be a big problem on the backside because the belt drive, there's no room for that plate unless you do serious changes. You could thread this so that this becomes a nut. That would be ideal. I don't think I have that size tap. I certainly don't have the way to machine this. That tap would be about $400, and I'd need the other side of it too. So it'd be almost $1,000 just to get the tooling to machine this to upgrade my tooling to be able to do it. So that's not going to happen either. We're just going to cut this slot farther down so that we can engage the entire timing pulley. So I fit a piece of 4mm square keyway. It just got a long keyway. Fit it in there nice and tight so I can line it up so it's straight up vertical. That should be close enough to cut the slot for a vertical cut. Kept turning and locking the spindle until that looks straight up by eye. I'll probably put one of my squares on it. It still looks crooked in the camera. As far as the surface, I just put it flat on the surface in the vise because the vise flat is actually already set up. It's probably a 1/1000 and 8 inches. Not anything to worry about. I've switched to a collet chuck because it's way more accurate, especially on a small solid carbide bit. If you look, I've lined the bit up with the indicator metal. It looks pretty darn good. It still has to go to the side a little bit. That's really irrelevant because this is a 1/8 inch bit. We're just gonna match what we got. 3/16 too big, 1/8 too small, but that's perfect. We'll just follow the old one and get it to where we want it. Just a little patience, take your time. It's a real small bit. We'll get there. Okay, that should do it. You can see it's looking pretty good. It actually fits perfectly with the keyway. So now the question is, can we just slam it home like we slammed it out? I've jammed in a couple of tight pieces of metal, fit against that really tight. Maybe we can just slam it home that way. We're gonna give it a try. Okay, just the way it came out. We're gonna try to put it back in. So far, so good. Okay, before we beat it up too much, let's put something in there. I'm gonna use a piece of scrap aluminum. And watch me, I'm gonna work with my left hand instead of my right. You think I can do that? Oh, look at that. The side came out. Hey. We might have to put it in the press yet. Not there yet, though. I haven't given up yet. Tighter is actually better. That looks pretty good. Let's give it one more try. That side's in. This side popped out. Obviously, we could put that in the press, but let's try. No. So what I'm going to do is I'm going to take this head off and I'm going to lay this down on something solid. So we've removed the spindle head. We put it on the vise. My vise has been machined true here, so if yours is not, you may want to consider putting a piece of aluminum there so you don't bang it up that section. We're going to drive this in with a hammer, and then we're going to drive this in with a hammer. Maybe I'll show you some video of it, maybe not. Hammering that in might be possible, but it was getting really ugly, so I put it in my homemade press, and it went together pretty good. Of course, I have some large pressing circles, so put it back on now. Get the spindle gear and motor in. There's several steps. Take your time, be patient. You're going to want these parts to just fit on there. If they're too loose, they're not going to work right. If they're too tight, you're probably going to have to take it off a bunch of times. So that ring goes with the groove. It's got a little groove cut out on the inside. The cutout groove goes this side over here. The flat surface on this side. Then you got this keyway. You're going to have to cut this slot in your spindle. If you don't have the capability, take it somewhere and get it done. The end result is there's two keyways filling up the whole space. You want this pulley to go on just smooth. Like that. If it's too hard, you're going to have to be able to get this off again. If you can't get it off again, you're going to get jammed and wreck it. Okay, the second keyway goes in after this pulley goes on, and it's going to slide in underneath. It's going to lock this gear in place. Notice this is cut out just like the last one. The cutout goes towards that side. This spacer is next. Notice the keyway is all gone. It doesn't come out the rest of the way. It cannot. If your keyway does, it's too long. If it's not right there, it's too short. You don't want it to be able to slide around in there. Next up goes the, the magnet holder for the digital display here. Everyone I know complains that this display is wrong after they put the motor in, and this is why. The magnets fall out. Okay, if you put this does not catch the keyway at all. In fact, there's no keyway slot. It holds the keyway in there. And then you have your two nuts. First nut is realistically hand tight. I'm holding it over here, turn it there. Second nut, I'm going to lock these together. The belt on. That's why I need them that loose. Okay, belt on. I'm going to take these washers up, these nuts up. I'm going to try it the old way again. You put a flat file, big one underneath here. Push down on this one. Lift up on this one. It's too much. We're going to try it because I want this motor to be straight. I'm going to try to get a bigger file for the top. So what I've come to is the motor's nice and straight. I had to move this till it's just holding the back while I push on the front so it stays straight. Now I'm going to tighten the bolts. Just push down on the front one. Check your belt so that it's running right up against this. You want it to just about touch. Felt pretty good. You're probably going to have to redo it several times to get it right because things tend to move and you want to get it just right. It's right up tight. We plugged in the control unit. We programmed the speed to run between 300 and 4,500. We programmed the braking at 2 and acceleration at 2. And that's pretty much it. $4,500 RPMs on the motor. 300 RPMs on the motor. We'll do test results on the spindle later and on this. That's pretty quick. I can make it faster, but it's yanking on the belt too much. So, and the first time I spun the whole thing right off. So 0, 4,500, 4,500 to 0. That's pretty fast. Go from 4,500 RPMs to 0 in 1 second. This yellow button has 5 settings for the brightness on that. Off, on, 2, 3, 4, 5. 5 being the bright. The belt cover on. Screw up till I just make contact. And notice there's a little bit of play. You might have to adjust that play for a quieter gear. Hear it? Work. Right there is where I want it. And could also feel the belt was hitting. Listen to that. The belt's hitting this corner a little bit. On the old ones we cut that off. I think we're going to cut it off again. Well, because we have better tooling, we just cut that off with the, ground that off with the belt grinder. You could probably do it with a file. Just a little bevel there. That's where it was hitting. We should have enough. Sounds better already. Not screaming like the old one was. Speaking of screaming, those little belt tensioning bolts that were in the back that I didn't use, when I was playing with the belt tensioner bolt and rubbing it, pushing it hard against the motor, it actually made that howling noise. You might be able to get rid of that howling noise just by removing those bolts. Set the carriage on, readjust these so that you have the proper slide. Or if you really want to do it right, true this all and fit shims in there so it's locked in exactly and has good play all the way. Notice it still binds a little bit right there and right there. Slide the half nut on the lead screw and start working it into place. Just one loose nut to kind of hold it semi together. Put this piece in real loose. Trying to work this into it. Of course, you can put this together one piece at a time too, rather than trying to flat rate it all at once. Never tighten up until everything's together. So we had this problem when we first started with the lathe. We were able to move the gear assembly farther out and it eliminated it, but that realistically only eliminated it in this area. As it come over this way, it starts hitting again. That's just like quality, but if we get the lead screw in just the right place, it'll clear. Real nice. We got this part off here so we can move the lead screw around. Lead screw's not bent. It is kind of tight. Shouldn't be that hard to turn. Yeah. We're going to have to shim or grind these blocks to get the lead screw lined up right. Another fine product from Vevor. So we took the lead screw back out again. And this part is right there. It's sticking and corroded, or there's something wrong with it in here. It's binding, so we got to fix that first. So I guess we'll put the lead screw in my other lathe and see right there, it binds right there. It's probably a burr right here. It looks like this is damaged or burred or swollen or machined wrong right there. Took the lead screw, chucked it up in my real lathe. Polished this journal inside. Spins free. Resurfaced the back of this block about 0.010 of an inch, so that we can move this lead screw closer to the lathe. Now it runs clear. And it turns good. And it locks good, so just a little off. Okay, so we installed the lead screw drive. Got that all hooked up and adjusted. And we'll test it. Remember how loud it used to be? It used to scream like a banshee. Not anymore. I think that's it for today. We'll work on it some more tomorrow. All this cover plate, realistically, it's just for looks. Maybe someday I'll get a good price on the gearbox, reversing gearbox that's supposed to go there. Install this style switch in the back of this cover. Center the sticker on the hole before you do it. It's kind of tricky, and maybe I'll show you that later. Put the knob on. Seal up this while you're at it, because this could get metal filings in here and wreck that. Might as well protect it. Install this on here. Run the speed switch wire through this hole first. It barely fits. Then run the power supply for the tack, plugs in here, through this hole. This is provided with the kit. Then run the RPM, spindle RPMs back through from the back side. Plug all in. Install the pickup for the spindle speed close to, but not touching the magnets. Put this cover on. The easy way to put the control unit on is to just put some two-sided tape on it and stick it on this plate right here. It's gonna have to go, say, here. And just plug everything in the back, I guess. Power on. 4500 motor, 2100 spindle. Let's put one on. So, if you buy a Vevor, plan to buy that too. $1,348, it's like 300 RPMs off. Okay, let's do a test cut and see where we're at. That should be about 800. See how it was lumpy before? Let's see if it still is. That's feels a lot better. That's pretty good. Let's cut a lot off and see what happens. Not bad. Let's try the loop 2, big cut. Well, the cut's a lot smoother. Hey, it could still use some more work. Better cutter. A little tighter on the carriage locks. And I bet you I could bring that into a totally perfect cut. That's all we're going to do on this for now.